Hallie's New Year's resolution is to work on her elliptical. She burns 349 calories the first day and plans to increase that number by 8 each day. So let's stop there and list out my first few terms. What is the first term in my sequence? What? 349. The first day is 349. On this, increase this number by 8. What do you have? What would you have? And then so on. Looking at these numbers, do I have an my adding multiplying? You're adding, we added 8 every time. So that means that it's arithmetic. Here's the question. By reading this question, we're going to determine, am I going to use sigma or am I not? Find the number of calories she will burn on the 30th day, assuming that this pattern holds true. So am I finding only the 30th number in the list, or am I adding up the first 30? What do we think? It is just the 30th term, because each day's number is the term. If you were going to use sigma, find the total number of calories she has burned in the first 30 days. So that's the difference. One is asking for the total, one is asking for that specific day. So this one we do not need sigma. Because it's arithmetic, here's the formula that I'm going to use. A1 plus D being A30. I'm finding the and then I'm going to plug in for N 30 and then type that in your calculator. 349 plus 8 times 30 minus 1. $81. Actually, in the activity you do today, I don't. It makes it easier to grade. All right, any questions on that one? Number 2. An auditorium has 14 seats in the first row. So we have a big auditorium. The first row has 14 seats. 16 in the second, 18 in the third, and so on. So each row You know, the closest to the stage has the fewest number of seats, and then the rows get longer every time. So start out by writing your first few terms. 14. Next one be 20. The number of seats in that particular row. Okay. So this is like row 1. This is row 2. If it has 30 rows. Total. You row 2 plus row 3. To use sigma. So in the total, we're going to do sigma. What do we always put at the bottom of sigma? N equals 1. And what's going to go at the top? And then over here we put the formula. It's arithmetic, so 14. Common difference. With sigma, you leave in there. You don't put a 30 in that spot. You only put the 30 at the top. So if you're using sigma, this has to stay an N. So x equals 1 to 30, and then I'm going to make my own parentheses and then close that. Get that typed in your calculator. What do we got? 1290 is correct. So 1,290 seats. Number 3. This one's a little different. I know I'm going to use sigma. Find the sum of the first 60 positive even integers. Oh, what in the world is that? Negative, right? It's bigger than 0. So even. What are even numbers? What? What'd you say? Did you say something? Oh. So even numbers are like 2, 4, 6, 8, 10, so on. And then integers, that's basically just a whole number, right? Which you assumed that anyway. So positive even numbers. Look at 6, 8, and so on. And negative even integers, it would have been negative 2, negative 4, negative 6, negative 8, and so on. If it had said positive odd, that would have been 1, 3, 5, 7, 9, and so on. So I know that I'm going to need to use sigma. N equals 1 on the bottom. What's going to go on top? 60. And then I'm doing my formula. Is it arithmetic? So I've got to use my arithmetic formula. On all of your questions, I give you both formulas, and I label them arithmetic and geometric. Formulas on the test. Okay. Plus, what's my common difference? What? 2. And then n minus 1. $3,660. Questions? Number 4. The football team is running a jackpot in which the prize will start at $1,000. Game 1, they've got $1,000 in the pot. And I guess they're selling tickets and winner at every game. So this $10 each additional game until there is a winner. So it starts at 1,000. The next game, it's got more money in it. The game after that, there's even more money in it, and they're trying to get a winner. So what would my pot at game 1? Won this. So at game 2, how much money is in the pot? At least by 200. So more than that. How much will be in there at game 3? 1,400. Okay, and so on. We want to know how much is in the pot at the 16th game. First of all, is this arithmetic or geometric? Arithmetic. Good. Here's the big question. Am I wanting just the 16th term, or do I want to add up the first 16? It is just the 16th term. That's how much is in the pot. I'm not saying third game is 1,400 plus 1,200 plus 1,000. That's going to be a whole lot of money, right? game is the 16th term. This makes sense for you to ever need the sum on this specific problem. Okay. So it's just the 16th term. And it's arithmetic, so I don't. So A1 is 1,000 plus, what's my common difference? And when you're just finding a term, you actually need to plug that in, get your answer.
I apologize for the interruption. I do need all teachers to check your email. We have a very important email that I just sent out about dual credit students at RCHS. Thank you.
Any of you in dual credit?
Yeah.
Okay, at 1 o'clock, you've got to go to the auditorium. So, that's in 10 minutes. Okay. So when I left that running. Oh. All right. What answer did we get? $4,000. Very good. Number 5. After the first year, Jackson's truck is worth $38,000. If the truck depreciates, what does the word depreciate mean? Goes down. So if it loses value, you buy a car this year, in 5 years from now, even if your car just sat and you didn't put any miles on it, no damage, it would not be worth as much money. They depreciate. So let's say that it depreciates by 10% each year. And normally that's the case. It depreciates by a percentage. Anytime you see a percentage, it's going to be geometric. Always. If you see a percentage, you know it's going to be geometric. Right. The information the problem gave us is that it's losing value. But what we care about is the percentage that it's maintaining, because it matters to you what your vehicles are worth. So if it loses 10%, what percent does it keep? What percentage of the value is it holding or maintaining? 90. You lose 10, that's you left with 90%. Also, with these problems, we don't want to put a percentage, we want it as a decimal. So if you take your percentage and you divide that by 100, it'll convert it to a decimal for you. All right, so now let's get into that. So we're starting with $38,000. That's how much it's worth year 1. Year 2, it's only going to be worth 90% of the previous year. So multiply that by 0.9. And you get 34,200. So that's year 2. Then we would need to multiply by 0.9 again to get year 3. Okay, and so on. So this one is geometric because we're multiplying by 0.9. And we want to know the value after 8 years. That is the 8th term. Your truck, at the 8th year, I'm not going to add all of those together. That would be way more than the truck is worth. It's just the 8th term. So AN equals A1 times R to the N minus 1 power. So then I fill in my A1, I fill in my R, and my N is 8. You get what? Yep, that's fine.
18,175.
Yep, and then 28 cents. So with money, it's always 2 decimal places.
When we're dealing with money, should we round up or just leave?
Well, it stays the rounding rule. So if I look after 8, that number is less than 5, so it stays in 8. If that was like 286, I would make it 29. But I'm not too picky on that. As long as it's like one or the other. Either you leave it at 8 or you don't. Alright, any questions? Number 6. An insect population is growing such that the number of insects is 1.2 times larger than the previous generation. If it's 1.2 times, that doesn't mean we're adding 1.2. That means we're multiplying. So it's going to be a what type of sequence? Geometric. Yep. So it's each year it multiplies by 1.2. Suppose the number of insects in the first generation is 100. So my first term is 100. How am I going to find my second term? Times that by 1.2. And you get 120. And then times that by 1.2. And you get 144. And so on. Good. And it wants to know the population in the 11th generation. So we're finding the 11th term. When we say the population, when they do a census and they say, okay, the population in 2010 was this many people, you don't add the previous years to that because a lot of the same people were alive in the previous census. So some of those people would be counted twice. So you don't add them up together. It's just each specific term. So the 11th generation is the 11th term. So A11 is A1 times my R, which is 1.2 to the 11 minus 1 power. $619.17.